Hello and welcome to StressOff. This is the place where we conduct finite element analysis using several different softwares that are available in the market. Some of them are open source softwares like FreeCAD, Calculix, and Salome Mecca. Some of them are softwares that are to be paid for, like Autodesk Inventor, ANSYS. Some of the softwares like PrepoMax are closed source, but they use Calculix as their finite element analysis engine. All of these softwares will be using to conduct a finite element analysis of a cube. The length of the cube is 1 meter, width of the cube is 1 meter, and the height of the cube is 1 meter. So it's 1 cubic meter cube. The pressure to be applied on the top face is 1 megapascals, and the bottom face will be constrained. There are a few different constraints that we'll be trying out in this software StressOff, so stay tuned. Hello and welcome to this week of StressOff. My name is Dharmit Thakur, and today we are going to use Autodesk Inventor professional software to do stress analysis of the cube with 1 megapascal of pressure on the top and different fixed conditions on the bottom face. Let's get started. I'll create a new file. Once when the file loads, we can start creating our cube. So I'll click on extrude and I'll make sure that I select the proper plane. From that, I just go in and select a rectangle with center point and corner, and I'll input the values for the two sides of the face, which are 1000 millimeters. I'll finish the sketch and I'll make sure that the distance that it needs to be extruded is 1000. So now when I click on OK, we have a cube which is 1 meter long, 1 meter wide, and 1 meter high. Now let's conduct stress analysis on this, but first let's just save this file. Next, let's click on stress analysis and create a study. We are going to create a static analysis. Once when that's done, we need to make sure that the material that we are selecting is similar to the materials that we have for other studies. Now the material that is being used here is mild steel, but when you check the physical properties, the mechanical properties, Young's modulus and Poisson's ratio are not what we want. So I'll just quickly convert them and enter those values here. So now here, let's see what are the standard units that we have. So in here it is 2.2 into 10 raised to 5 megapascals. Now we need to change that. So for that, what we'll do is we'll duplicate this material and we'll just say this as for FEA, or we'll just call it for StressOff. Description again is for StressOff. Appearance, we are not concerned much about it. Let's go in and add the properties that exactly what we want out of it. So now let's change from MPa to PSI, and we want that. So let's click this in the PSI values. And the only reason we are changing the Young's modulus and Poisson's ratio is for the fact that we want to keep everything same for all of the other simulations. So let's say apply, and then we'll say for StressOff is the metal that we want. So let's close this, and you can override the material here and call it for StressOff. So we have changed the material. Now let's make sure that the bottom, now in other softwares like FreeCAD, we were able to just make sure that if we just fixed Z direction or Y in this case, which is vertical, so if we fix just the vertical constraint for this cube, it would solve. But for this scenario, it will not do the same thing. So if I just say I want to stop it going in Y direction, and if I try to solve it, it won't solve. Just to prove my point, let's do that. Let's apply a pressure of 1 megapascal on the top face. Let's go in and mesh this. The mesh average element size is 0.1. That's the reason why we are getting 10 elements on each and every edge. Now we are not going much into detail of quadratic elements and things like that for the sake of this video. Now when that is done, if I try to simulate this, it will say that there is an error. It says not enough constraints. It means that we won't be able to solve this just by putting Y constraint only. So let's go in and let's just say we would like to constrain X, but that constraint would only happen for this edge, and I would like to constrain in Z direction, but that only happens on this edge. After we add these two constraints, which you can see here, let's go in and simulate, run, and as you can see, it did a clean simulation. By default, Autodesk Inventor gives you 1 ms stresses, and as you can see, the maximum stress you can see is 1.000 something megapascals, and that is consistent everywhere. Let's check the displacement. Displacement of this is 0.005173. Now one thing to consider here is that the displacement that we are interested in is only in Y direction. So let's open this displacement folder and just click on displacement in Y, and then you get the displacement of just the top face, which is 0.004762 millimeters. So in other words, this is 4.762 micrometers. Now this same analysis, what happens if we just make the bottom face as fixed? Let's conduct that analysis. So this is all good. Let's create a new study. We'll reuse the same thing, and for material, we'll change it back to for StressOff. For the constraints, we'll just say we want a fixed constraint on the bottom surface, and we want 1 megapascal pressure on the top surface. Let's mesh this and run this simulation. As you can see, the maximum 1 ms stresses that you're getting is 2.3 megapascals, and that too is predominantly in the corners of the cube. That too for the bottom face only. The deflection, if you look from the side, as you can see, because the bottom face cannot move, the size of the bottom face remains as 1 square meter, and you can see the deformation happening in such a way. How about let's just change the value of deformation. As you can see, when you change the value or the amount of deformation, you can see how the entire block is deforming. But if you say actual, you won't be able to see any deformation as such. So let's just do an adjusted deformation of 1. This was just the 1 ms stresses. If we go to displacement, here it is showing 0.004775 millimeters of displacement, which in turn is 4.775 micrometers. Now, if we still want to see the displacement in y direction, we can go in and check. The y direction displacement is 0.004661 millimeters or 4.661 micrometers. So that's it, guys. This is use of Autodesk Inventor Professional for StressOff, in which we are conducting stress analysis of 1 cubic meter with 1 megapascal of pressure on the top face and different boundary conditions for the bottom face in all the several different softwares, and we're getting the results out of it. If you liked it, stay tuned. Next time we are going to use a different software and we are going to compare the results. Thanks, guys.